Can you guys hear me?
Yeah, I can hear you. I was on mute. Sorry.
Yeah, sorry.
Okay.
Sorry for the delay, MC.
No, there is not. We are on time.
Thanks.
Okay. Okay. Hi, how are you?
Oh, very good.
Yeah.
Abhishek, how are
Okay.
you?
Yeah, I'm fine. Let me know how can I help you?
Oh, I sent the material, right? The two
Right,
questions.
right. Right.
Uh, A little bit of theory and then the
Okay.
steps. They already
Okay.
gave the example, but then I thought instead of blindly doing something, let's do it in a nice way where
Right,
we
right.
understand what we are doing, why we are doing, and some theory.
Right. Okay. We can start the discussion. Okay. Okay. See, here they have given you one. First of all, I will start discussion FET. Okay.
Hmm.
Field effect transistor. Okay.
Hmm.
I'm not going into the detail that is what is the FET and all those things. But
Like
basically, yeah.
just the object understanding, right? Like yesterday
Right.
you said
Circuit.
about the drain, the
Yeah, gate, drain, and
gate,
source.
gate, drain, and source. So gate is like the, I mean, not exactly maybe, but little bit like the base, right?
Right. And
Just
we
for
have,
understanding purposes.
yeah. You can relate it. Okay. You can relate it with the base. Okay. This is 10M. This is RS that is given in the question 220 ohm. Okay.
Hmm.
And this is VDD. Okay. And this is RD that is given 1 kilo ohm. Okay. Okay. Now they are asking what are the VG? What is the ID, sorry, for different value of VGS? Okay, just I'm giving you a little bit theory about this
Hmm.
one. See, the current flows in a field effect transistor. Okay, for yesterday I told you that these type of devices are voltage controlled, right or wrong?
They are correct, right?
Voltage control device. Okay,
Yes.
so basically, if we are giving some voltage here, it will develop some potential here, right? That potential is known as VGS. Okay,
Mm-hmm. Hmm.
that potential is known as VGS.
Hmm.
Okay, and we required some minimum potential VGS so that this device can start working. Okay,
Mm-hmm. Hmm.
so there is some minimum VGS required that is known as VP pinch of voltage. Okay,
Hmm.
that is VGS off also known as, that is equal to VP, that is pinch of voltage.
Hmm.
Okay, that
Hmm.
is the requirement. Above this voltage, if we can increase VGS above this voltage, our device starts to conducting. Okay,
Got it.
and current start to flow. Are you
Hmm.
getting me?
Yeah, same thing like the 0.7 for the BJT.
Right. That we need VBE 0.7 for
Hmm.
for that to flow. But it is many things are different here. But yeah,
Of course, just as a
yeah.
understanding point.
Right. So it is that when a voltage is applied to gate, an electric field is created, okay, which in
Hmm.
turn create a depletion layer in the channel, and this depletion layer reduces the number of free charge carrier in the channel, and thus when we are decreasing the voltage, okay, that is the different thing. Okay, basically you understood, right?
Hmm.
Basically, let me for a small thing just tell you, this is like that. Its
Hmm.
basic circuit is like that. This is source, this is drain, and here we used to have a something like that oxide layer. Okay, here
Hmm.
we put gate. This is oxide layer. Okay, and this
Hmm.
is the channel between drain to source. So what happens, we put voltages here, and the current is getting developed here. Okay, current start to flow, you can understand in this way. Okay, and we
Okay,
need some minimum voltage. Okay, so that current will flow.
got
Okay,
it. Hmm.
any doubt?
No doubt.
Okay, very good. So basically, we are required to consider the VGS. Okay,
Hmm.
for the for VGS, VGS is an important para. Just I want to tell you. Okay. Now I will give you directly the formula. Okay. What do you mean by ID and all those things? Okay. Okay. ID formula. This is field effect transistor. This is FET. We have Mostfet also. Okay. There are little bit difference between Mostfet working and field effect transistor working equation wise. So I'm not going it because it is field effect transistor. Okay. It is IDSS 1 minus VGS VP whole square. This is current equation of a field effect transistor. Any doubt?
No.
Okay. And depending upon the, you can see for this current to be positive, VGS should be greater than VP, right or wrong?
Yes, it should be.
It will be positive anyhow. For any time it will be positive because it is square, but this should be positive. Yeah, tell me.
Yeah.
Okay. Okay. Any doubt?
No.
Okay, that's fine. Okay, these are the small theory about this question. Okay, now we can take up the numericals. Okay. Any doubt?
No.
Okay, very good. Okay, what is your question? Let's see. What is your exact question?
So you're a full-time instructor?
No. This is just a part-time. I'm doing.
Oh wow.
Okay. I'm doing job in Intel. You have heard about the name company Intel. I am.
Yeah, Intel, is it?
Yeah, Intel. I'm working here, but as a part-time, I am doing this one. These days, we can do work from home, so according to our work, we can manage it and
right.
Okay. So now IDSS is given, right? IDSS is given, right? That is what? 9 milliampere, okay? Okay. And VGS off is given, right? Minus 8 volt, okay? Now, you can see they're asking you different voltages and all those things, okay? For different, find ID for different values, okay? Okay, let's start finding ID. ID equal to IDSS 1 minus VGS by VP, right? And VGS off is VP. Okay. The last slide I told you. Okay.
It should be greater than VP.
Yeah, it should be greater than basically. Okay. So VGS, no. I am telling that VGS off is VP.
Okay. The minimum one is
requirement. Yeah.
Okay. Okay. Got it.
After that, the current flow. So here, do not get confused by negative. Here, the negative voltage is after the negative voltage, we can have the current. It is like that. Suppose this is your VGS. This is your VGS off. So after this, your current can start to flow.
Got it.
Got it? Okay, fine. Okay. Now this is, now we have to calculate when VGS equal to 0. Okay, this is your VGS off. I'm doing I draw the graph so that it can be visualized. You can visualize it. Now they're asking you to find current at this point. Okay, ID. So ID at this point will be what? 9, 1 minus 0, VP. This is whole square also. It will be 9 only, right or wrong?
Right.
Doubt.
No.
Okay. Now take the another point. You have to find for VGS equal to minus 1. For VGS equal to minus 1. For VGS equal to minus 1.
Why we have to give -1? They asked, is it in the exact question?
Right. Yeah.
Okay, different values they are asking. That's all, right?
Right. Minus 1 and VP is minus 8. Okay. So basically it is 1 minus 1 by 8. Basically it is 9, 7 by 8 whole square And if you will calculate it, can you calculate these values? 49
Okay, I can
divided
do
by
that.
64. Yeah, 29. Yeah, I think you will get your answer of ID. That will be around 6.89 milliampere. Okay.
Hmm. Hmm.
Any doubt?
No.
Okay. If any doubt, you can ask me. Yeah.
Hmm.
No doubt, right?
Hmm.
Now you can see they are asking you voltages at minus 0.4. Here
Hmm.
I found it, right? Minus 1 I found. Now they're asking minus 4.
Is it the
From
same
the
thing? Putting it in the value and checking it?
right. It is the just same thing. You can check the
Then
values.
I mean, if it is the same thing, I'll do it, Abhishek.
Right? Yeah. It is the same thing. Now,
Okay.
now they have asked you find VDS and VGS also. Drain to source voltage and gate to source voltage also. You can see
Hmm.
in the downside, right? So
Hmm.
what is drain to source voltage and what is gate to source voltage?
Hmm.
You can see. Okay, this is RS. How can you find drain to source voltage? Drain, this is gate, this is source. Okay, now you have to find VDS and VGS. Okay, for finding VDS, I will move in this loop. Okay, I will move in this loop and I will find it. Okay,
Hmm.
let's start moving in the loop and let's start finding it. And for that, they have given ID. Okay, for that, they have given ID as a 5 milliampere. Okay, now can you apply Kirchhoff's voltage law from VDD to ground? Can you apply?
Okay.
Before that, can you tell me how much current will RS will have? Can you tell me how much current RS will have?
Same like BJT, like the current from drain to ground and this RS, they have to equal, is it?
No, in the
I,
BZT, it was not equal, right? We have the IB. In the VZT, we have IE equal to IC plus IB,
that's what
right?
I'm saying. Same thing here. I
Yeah,
equal to IC plus IB, right? So here also IS equal to ID plus IG kind of thing, is it?
right. But I told you that the basic difference
Current
between
is
that
not there. Voltage, current is
current
zero here. Okay,
current
got
is
it.
0. So ID
Uh,
equal to IS equal to 5 milliampere,
okay,
right?
okay. Yeah, right.
This is the concept here. Okay,
Yeah,
so if
high,
we,
yeah, voltage will be there, current will be zero,
yeah,
IG will
yeah,
be.
yeah. If we'll apply the Kirchhoff voltage law,
Hmm.
VDD equal to IDRD, right? One plus minus voltage there drop will be there, VDS
Hmm.
plus IS into RS, right? Since
Hmm.
ID equal to IS, we can just put VDD equal to IDRD plus RS plus VDS. So our VDS will be nothing but VDD minus ID into RD plus RS. And what is
Okay.
your VDD? VDD is plus 5. This is 5 milliampere. RD is 1 kilo ohm and this is 0.22 kilo ohm because it is 22 ohm. So basically
Okay.
it is kilo ohm, milli and kilo ohm will get cancelled. Okay, 10 is to 3, 1.22 into 10 over 3. It cancel, you will get 15 minus 5 into 1.22.
Okay. And
That will, yeah,
the
you will take it,
calculations
right?
I'll take.
I
Yeah.
think you will take it, right? It will be around 8.9 volt. Okay, you will get
Okay.
7.1, it will get 800 volt. Okay, any
No,
doubt till now?
no
Okay,
doubt.
okay. You can find VGS also. Can you find VGS?
So VGS will be
That is a major challenge here.
so VGS will be VG if we take the inner loop,
Right.
so
This loop.
ISRS is some voltage drop, then VG there is some voltage, then
Right.
VGS. VG
Right.
plus VGS plus ISRS. Huh?
Right. So basically we can apply there. We can apply IGRG, right? In the KVL in inner loop. KVL in inner loop. Okay, inner loop. IGRG plus VGS drop plus ISRS, right or wrong?
Right.
Since we know IG equal to 0, then we can have VGS equal to IS minus RS, right or wrong?
Right.
And VGS, IS we know that is 5 milliampere, and this we know 220 ohm, right? So basically it will be around minus 1.1. Okay, got it?
Got it.
Just a small concept is there only, that ID equal to IRS, and you have to be careful in applying Kirchhoff's voltage law. Okay, you will get your answer.
Sorry,
These
what
questions
should I be careful?
Kirchhoff's voltage law you have to apply, and you
No.
have
You said
to
be careful. You said right, like current minus.
you have to be careful about the current. That ID should be equal to IS. Okay,
Got it.
but that you have to be careful. Okay, okay. Any doubt here? Huh?
No.
No, we can move to the other question, right? Okay, very good. Okay, can you read the question with me? Use a MOSFET to switch current. We have a device with digital IO port. Okay, okay, a Raspberry Pi etc. Okay, which can source 1 milliampere. We want a device use digital IO port which can source 1 milliampere. We want to use this control on LED which needs 20 milliampere. Okay, and has forward voltage drop of 2.9. Assume as a 5-volt power supply is used. Okay, DIO output is 3.33 volt logic design circuit. To this W MOSFET, choose a device where carefully useful for logic level MOSFET using N-channel enhancement mode MOSFET. Okay, they have given some values. These circuits was given in your question, or you have drawn the circuit?
No.
These all things are given in your question, right?
The exam units are given. This
These
diagram is
MOSFETs,
they will not give.
yeah, that is my point. Because if they are giving diagram, so that's making our job easier, right?
No, I
That is
don't
my
think the diagram will come. This is just whatever the answer they gave.
okay. So you want me to design this the diagram, and what will be the various units, right? Okay, very good.
Nothing.
Okay,
I mean, answer is there. We have to just understand the theory and then how.
understand. Yeah. Because that's why I'm asking. Because I should take the question in that way, that till then the question will come. Because
Correct.
if they are giving the diagram, then they are making our job 50% easier. That's why
No, I don't think they
they are
will
not.
give.
So I have to explain you that how we have to draw the diagram and
Exactly.
how we have to get these values, right?
Correct.
Okay, so first of all, see what is with us, what they have given to us, right? Okay, we have to use a MOSFET to switch current. Okay, switch current means that there should be two current values, right? In which we have to I have to use MOSFET to switch two different current at different instant of time, right? Okay, based on the input values, right? So first I will draw since they have told that you have a MOSFET. Okay, I will draw one MOSFET. Okay, now I am not drawing that whether it is whether it is n-type, p-type. I don't know, because I will read the question. After that, I will come to know that whether it is n-type or p-type. Okay. Okay. Which can source 1 milliampere. Okay. Which can source 1 milliampere. Okay. Source current is 1 milliampere. Okay. No issue. And we want to use this control and LED which needs 20 milliampere. Okay. We have a LED that needs 20 milliampere. Okay. At the
That's
output. Right. Milliampere. And has a forward. It means that we have a LED. We can have a LED like that. Okay. And this has a drop of 2.9 volt and its take current 20 milliampere, right? I'm just drawing the LED as a separate unit. Okay. And assume a 5 volt power supply is used. It means that we will have some power supply VDD that is 5 volt. Okay. So basically we have, from the question I came to know that three parts. We have one VDD, one MOSFET and one LED, right? DIO output. DIO must be a something device. Okay. Outputs 3.3 volt. It means that I think DIO is a is output. Okay. So our output is 3.3 volt. Okay. Now
input.
design.
That is our input.
Okay, DIO output. Okay, what is DIO? I don't know. What is DIO?
No, what they're saying is it is some kind of a this controller, right? MSP 430, which is outputting this voltage of 3.3.
Okay.
For us, it is the input, I think. This 3.3, according to the diagram.
Okay.
Right?
So basically, it is 3.3 volt. Okay. Okay. Design logic circuit to this W MOSFET. Okay. We have to design, choose a device where fully our logic level MOSFET. We can use N channel. This is our N channel. Okay. This is our N channel. Enhancement mode. Okay. This is our N channel enhancement mode.
But the direction they get from the source, it is going up though. I don't know why they.
Yeah. Enhancement mode, it's like that only. Okay. Enhancement mode, it's like that only. Okay.
The previous one was not, is it?
No, previous was a normal mode. Okay. See, there are difference. I will, at the end of the class, I will let you know that what is the difference between enhancement mode and depletion mode. Okay. Okay. So that if the next time the depletion mode come, you can take it as a new one. Okay. For now, if suppose this, they would have asked you that this is depletion mode, then your diagram will look like this one. Like this. Okay. This is a solid line will be there. Okay. Here we have a dotted line. Okay. In that way, the depletion layer and those things are there. Okay. Okay.
And N-type and the previous example was what? P-type, is it?
No. This is the field effect. See, if nothing is given, right? If nothing, whether it is depletion, so we can directly use diagram like that, and we can make it in like that fashion. Okay, if there are a lot of connection is there, that is depletion and something like that, then we are making it something like that for N-type. See, it is going inside. It is
previous example, you just gave like 2 lines, and then you said G and S. Okay. And there were directions, like from S it is going inside, like our emitter
like
bias, right? Whether it is coming out or coming in. N-type, P-type. That is what I'm.
See. This is N-type. By default, we are drawing N-type. It is like that. Okay. It is like that. Okay. If it is going inside, it means that it is coming in this way. Okay. We draw in this fashion here. Are you getting it?
I didn't get that. Like, if the arrow is inside, what does it mean?
This means that it is N-type. Okay.
If just the arrow is arrow, but the current wise, it is still from the drain to source. The current is flowing,
right. Current always flows from top to bottom, from higher potential to lower potential.
Then how this arrow inside or
See,
outside?
this arrow is like that. Okay. This
N
is
type.
N type. N type.
N
Okay.
channel.
Now, this arrow we are mentioning that because the current is flowing in this way. Okay. That's why we are mentioning these arrows. Okay. And this arrows coming like that. Are you getting it?
Okay.
Okay. And suppose it is P type. Suppose it is a P type. The arrow will be like that. So current will be coming in this fashion.
Oh, it will not be coming down from source to
Yeah,
drain.
yeah. In the P type, you will get to know that at the source potential will be high and drain will be grounded.
Got it.
Okay. Okay.
Yeah.
I will give you the exact diagram, exact symbol of N type enhancement, N type depletion, P type in depletion, and all those things. Okay.
The
Okay.
best thing is, Abhishek, after
Yeah.
this, if you say, okay, if this is what we have done, if they
Right.
ask for
Right.
this example in variation of
Right.
this, then okay,
Right.
make
Right. Yeah, I will give
make
you the
this change. Only the difference.
difference. Yeah, four different diagram: enhancement, depletion, and all those things. Okay, so that when you get the new question, probably you will get the new question in your exam. Same question will not repeat, so you can easily able to do it. Okay. Okay, and this difference between depletion mode and enhancement mode are that enhancement mode see, enhancement mode we have to apply gate voltage, okay, to have the conduction. But in the depletion mode we are having the conduction before applying the gate voltage. Okay, even gate voltage is not there, we are having the conduction.
Sorry, please repeat.
Okay, I'm just telling you. Enhancement mode needs a voltage to turn on. Okay.
Yeah, that VP, we pinch.
Yeah.
Okay.
But depletion mode the MOSFET is already turned on, and the MOSFET is already turned on. When your VP is not there, even then your device is turned on. In depletion MOSFET, we need voltage to turn off. Are you getting the difference? In enhancement mode, we are giving the voltage to turn on the device. In depletion MOSFET, we are giving voltage to turn off the device.
Got it.
Got it? Okay.
Got it.
Okay. Okay, then coming back to the question. Okay. Okay. We have one LED, 2.9 volt, and they have given one VGS threshold. Okay. VGS threshold. This is MOSFET. This is MOSFET, and earlier was field effect transistor. Okay. This is MOSFET. In MOSFET, we have the gate source threshold voltage. Okay, gate source threshold voltage, and this gate source to voltage should be greater than this gate source threshold voltage for the conduction, since it is enhancement mode. Okay. Okay, understood? And this gate to source voltage is 1.3 volt. Okay, and this RDS on, drain to source RDS on, they are telling it to be 1 ohm. Okay, basically they are telling that this is drain and source. Basically these nodes have one resistance RDS. Okay, that they are telling RDS on. Okay, any doubt in the understanding of the question?
Which VGS?
Sorry,
VGS is greater than
VGS threshold. VGS should be greater than threshold to turn on device, to turn on. This is threshold voltage. Threshold voltage, what? The minimum voltage required to turn on anything, right or wrong? Suppose you are
what was the pinch one example? That was VG.
Pinch off. Yeah, pinch off was coming in the field effect transistor. Okay, VGS off.
That was the previous example is FET. This one is
FET.
MOSFET.
This is MOSFET, right? That's the difference I want to tell you. Okay, so here the terminology and the notation to give the equations will get changed. Okay, you have to be careful here. Both are different. Okay. Functional wise, both will be same, almost, but current equation and all those will be changes. Okay.
Maybe the better option, I mean, just a request if it is possible.
Yeah.
You explain me this and then say, okay, this later, maybe writing in this might be difficult for you. I don't know. This one, or maybe on a separate paper, and if you give it to me is, okay, your first example was FET and this one, right? And the second example is MOSFET and this one. And so these differences. So based on that, I know that, okay, if it comes, okay, this is what we have done. But from FET to MOSFET, this is what we have to remember. So that way I will slowly learn and then try to remember that way, so that
the thing is that if you want to solve this question with FET, and if you want to solve the last question with MOSFET, every parameter I need every parameter. Here I need VP off and many other parameter I need. Okay, are you getting me? Basically here, if every parameter will be the new for me, because I have because in MOSFET to find the current, I'm just telling you the MOSFET equation. To find the current, we know mu1 Cox W by L. This is the current equation of a MOSFET.
Oh, the equation is completely different, right?
Completely different. So I want to have these parameters. Okay. I want to have these parameters. Okay. So they are designing the question in such a way that so that you will not require those parameters, right? Here the ID is nothing. In the field effect transistor, ID is nothing. One thing I will do, I will draw one line for FET and one line for MOSFET, and I will write the different current equation of both of them. Okay, so that you can have the idea that how we are differentiating it. Okay. Okay. Let's try first this question. After that, we can do it. Okay.
Got it.
Okay. Now we explained the question that at the output we will have one LED that will give us one output that will take up 2.9 volt to turn on, and when it's turned and it's required 20 milliampere. Okay. Okay. So basically we will have one VDD, right? One VDD of 15 volt. We will have one resistor here, because we cannot connect any diode directly with power supply, right? Why we do not require any diode to connect with the power supply? Because the diode has some limitation. Suppose if my device is turned off, then when I'm connecting my diode directly with VDD, then a lot of current can flow through the diode and my diode can get damaged. So that's why for every electronic circuit, we cannot connect any electronic circuit directly with the power supply. We have to put some resistor there. Okay. And that resistor, we can put any R. Okay. Okay. And this is 2.9 volt, right? Right? They have given in the question, right or wrong?
Yes.
Okay. Forward voltage, it assume a 5, and this is 5 volt pulse. Okay. Now what we have to design? We have to design this R. Okay. We have to design this R again. We are giving one power supply here, input here. So we have to connect with one RG, right? One resistor. Okay. One resistor, and this will be our input. Okay. Any doubt?
Yeah. No.
Here in the figure, they have connected one more resistor. I don't know why they have connected, but I think this is the this is the primary requirement of your devices, to have the resistor at the with any power supply. Okay, when you are connecting with the any power supply. Okay, so basically I have drawn the MOSFET, and I have to find these resistance value so that I can design this MOSFET transistor. Okay, now coming to the question.
The resistance, they written that prevents too much inrush current.
Which one? This one is the requirement. They have also prevents too much inrush current into the gate, prevents ringing. It means that it will prevents that too much current will not flow to this gate, so that the gate will not get damaged. Even
the other
though
thing the 10K they said ensures gate has a default no state.
Yeah, no nested. Yeah. It's right. Okay. Basically, what we are doing? This current IC is 0, right or wrong?
Sorry?
Right or wrong? This IG should be 0, right or wrong?
Yeah, it should be 0. Correct.
So when we are supplying some supply here, it will creates some current, right or wrong?
Yes.
That current, if it's not going into this one, where it should be go? It should have some path.
Yeah.
That current to get vanish away, right or
Okay,
wrong?
got it.
Otherwise, it will damage our device, right or wrong?
Yes.
Because the basic function of our device cannot be changed. We
Got it.
cannot inject current inside the gate. We have to provide a path so that the current should flow, right or wrong? Because since we are giving a supply, if we are giving supply, voltage will develop, then current will also develop. You have to mind it. It's not like that only voltage is developing. If it is 3.3 volt, then it will develop some current also, and that has to pass through it. Okay, any doubt?
No doubt.
Okay, now we can find this R value. We can apply one Kirchhoff's voltage law here. That is VDD into ID into R, right? Plus 2.9 volt, right? This they have given that as a one resistance, RDS on. Okay, and that is nothing but RDS into ID. Any doubt? And what is your ID? Can you tell me? In the question, they have given you ID.
Okay.
Can you tell me what is your ID? Read the question. Don't see the solution. Read the question. There you will get that what is ID. What should be the ID?
Okay. 1 second. Let me read it.
Yeah.
And has forward. Oh, yeah. 20 milliamperes.
20 milliampere. Very good. So we can have VDD 20 milliampere into R plus this RDS on plus 2.9, right? And VDD is 5. 5 minus 2.9 divided by 20 equal to R plus RDS. Okay. And R is given, R is unknown to us, and RDS is unknown to us. RDS is nothing, but RDS is what value? RDS must be given in your question. RDS. We have the logic on. Yeah, RDS on is given 1 ohm. Okay. 1 ohm is given. So we can find it, right or wrong?
Yes.
Okay. Now, second question. Second question to you. You have to find these values. How can you find these values? RG and this 10K. Can you tell me?
I'm not seeing your cursor. Sorry, which one you mean?
Yeah. This RG value. And I want to know. How can you find this? You got R value, right? If you solve this equation, you will get R value as 1.4 ohm. Okay.
Okay.
Now, since you are designing, then you have to know this value also, this RG. How can you find that RG? My question is to you is that.
I think they just estimated it, is it?
I don't know what they have do, but to find RG, just I told you that your gate to source voltage should be equal to or greater than VGS threshold, right or wrong?
Yes.
Your source is ground, right?
VS is ground, correct.
So how much gate voltage should you require, minimum gate voltage, to turn on this device? It should be at least 1.3 volt. Right or wrong? If I have 3.3 volt here and 1.3 volt here, and current they have told source current as a 1 milliampere, can I find RG?
Yes.
Are you getting it? They are telling that source current is 1 milliampere. Okay. So at least these values, this is, I'm telling of the minimum criteria. So RG will be what? 3.3 minus VG by IG, right or wrong? So 3.3 minus what is IG? IG is 1.3. This is your IG. IG is 1 milliampere. So that will be give you 2 by 1 milliampere, and RG that according to me 2 kilo ohm.
Okay.
Okay. It can be the lesser value also, because VG can be more than 1.3 also, right or wrong?
Yes.
Are you getting my point?
Yeah.
VG minimum value is 3. If VG is increasing, RG value will decrease, right? So minimum RG equal to 2 kilo ohm is required. It can be the lesser value also, but 2 kilo ohm minimum is required. Are you getting my point?
Yeah, but I don't know why they use 100 ohms, but anyway.
Yeah, because RG minimum, sorry, VG minimum is VG minimum is 1.3 volt. If we will increase the VG, then our RG will decrease, right or wrong? Drastically, it will decrease.
Okay.
Suppose your VG is
Got it.
3.2 ohm, 3.2 volt, right? Your transistor will be on, right or wrong? Because VGS is greater than VGS threshold, right or wrong? In that
Yes.
case, can you tell me what is your RG? It will be 100 ohm.
Okay, got it.
Are you getting the concept?
Yeah.
Okay. Any doubt?
No.
Okay. In this way, you can design your circuit.
Okay.
Okay.
Mhm.
Any doubt? Just
No.
now, I will just explain you that enhancement and depletion part. Okay.
Okay.
That diagram I can give you. It will be better for you. Okay.
Mhm.
To design any new circuit. Okay.
Mm.
Okay. Both are enhancement MOSFET. Okay. Both are enhancement.
Mm.
It means that it needs
Voltage to switch it on.
voltage to turn on. Yeah. To turn on.
Okay.
Okay.
Mhm. FET
This
FET is always on the, so the main difference, if I'm trying to understand, FET is always on the on state.
yeah, you can say, but it's not completely like that. See,
Okay.
FATE is also like that, but the working principle of FATE and MOSFET is different. In FATE,
Got
we
it.
have the field effect transistor, and MOSFET is metal oxide field effect transistor. In
Correct.
MOSFET, okay, in the MOSFET, what is there? In the MOSFET, we have one insulating layer between gate and substrate, and okay, and that is pushing it to get get electron to flow. But the fit with working is different. We do not have that insulating layer. Okay, it is directly giving the voltages, and it is asking the current to flow. In there is a one basic difference between those things. Okay,
Okay.
it is not like that fit is always turned on. You can see, if it will be always turned on, then why we need this VGS off? I told you that it is the VGS of, it is the minimum voltage that is required. After
Pinch.
it will be the
Pinch.
pinch of voltage. Okay, so it
Hmm.
also required some voltage, some minimum voltage to turn on. Okay,
Got it.
that is given by VGS off. Okay.
Okay.
Okay, it need, okay, this is N. Okay, this is N channel. This is your P channel.
Okay.
See,
The
in what fashion I
problem.
learned, I learned that this is N channel, this is P channel. I learned in
Clear.
this fashion.
That is the best way. Yeah.
That is the best way. But since in your exam, you can learn in this manner also. Okay. So, or if you have to do the only MCQ question, then you can do your own notation. Okay, because I also get confused in this one. Okay, but for learning point of view, you can understand in this way. This is going here, this is going here, outer, like this.
Yeah.
Okay, now
Okay.
coming to the depletion mode. Okay, depletion. Okay, depletion. In the depletion, you will see everything will be same, but we will have one solid line. Okay, because in the depletion, it has the pre-existing channel. I'm telling the word pre-existing channel, it means that we have the channel pre-existing without the voltage, or even we do not apply any voltage, we have the channel. Okay. Let me write pre-existing channel. Pre-existing channel. This is your drain. Okay. And again here, one solid line. It will be outside. It will be gate. It will be drain. It will be source. It will be your AND channel. Okay. And this is your P channel. Any doubt?
No, the main, I mean, just diagram wise, enhancement, there is a dotted line. Here it is not a dotted line.
Not dotted line, right? In depletion, you will have the pre-existing channel. Okay. If they have asked the same question with the depletion mode, then they would not have given this value. Because by default, this turn on value, threshold voltage. Okay. Because by default, it was turned on for the depletion case. Okay.
Okay.
For that case, it is not required to check that whether we have the VG as turned on or not. Okay. It will be automatically be turned on. So we can put any values of the register here to limit the current, and we can get the value, get our answer. Okay. Any doubt here?
No.
Okay. And one concept that I want to give here. Okay, that's not required in this question. Okay, this one, and I will write the current equation for FET and all those things. It may help you that in FET ID equal to ID SS 1 minus VGS by
VP
square.
This
where yeah,
this you already gave for to solve the first problem, which was a FET problem.
Right. Okay. And in MOSFET, we have some condition that I am giving you, that first VGS, if VGS get to source voltage, if I'm talking MOSFET, then by default I'm talking about enhancement. If in the question they have not mentioned anything, then by default you can take it as an enhancement, because depletion mode is a special type of MOSFET. Okay.
Yeah. So VGS should be greater than V threshold.
No, suppose first condition is VGS. Suppose VGS is less than V threshold, then our current ID equal to 0. Okay. Our second case is VGS is greater than V threshold. After that, in A part, our drain to source voltage is greater than VGS minus V threshold. Oh, first less than VGS minus V threshold. Then my device is in triode region. One region known as triode region, and that current is given by mu on COX W by L VGS minus VT threshold whole square VDS minus VDS whole square by T. In this way, it is given. Okay, I don't know whether in your some other question they will ask you. Okay, but I am giving the formulas. And there is one more case that your when VDS is greater than VGS. Yeah.
But it's bigger formula to remember, right?
Right. You have to remember it. But it is very easy to remember it. Okay.
How?
For this, yeah, I will tell you. Okay. This is this is saturation mode. Okay. This is these formulas you have to remember. If you see any this type of question that they have written triode mode, saturation mode, then you can understand that this type of question can come in your exam. Okay. This mu and COX are transconductance parameter. Okay. W is the channel wide. This is your channel. This is W. Okay. And this is your channel length. Okay. L is the channel length. Okay. To learn this formula, you can understand in this way. Suppose you have to learn this formula, then you have to learn it. Then basically you can learn, if you learn this formula, then you can learn this formula. Anyway, you have to learn this one. Then you can learn this one, because when you VGS minus VT whole square into VDS minus VDS whole square divided by 2. If you put VDS equal to VGS minus V threshold here, then you will get this formula.
Okay.
First of all, you check that whether these are required in your notes or not. But I think it will be required. I think it will be required. It must be in your syllabus. If it is in your syllabus, then you have to go with the detailed analysis of these things. You can check.
Okay.
But since I saw your last question, so I guess that it is required in your syllabus. It's because last question is an advanced level of question. So they must have this type of question in your syllabus also. Okay. It's like that only.
Got it.
Okay. Hope you understood it and you can make it up. Okay.
Yeah.
Try to revise
Okay,
it. If you have any doubt, you can ask me. Okay. Okay. Thank
Super.
you. We can.
Thank you so much.
Okay. Bye. Bye.
Bye.
Uh,